As a control for the experiment, I'm going to shake this can for 15 seconds without tapping it to see how much it foams. 15 seconds and open it immediately. So as you can see, the foam does overflow. Now I'm going to do the same with this one, however I'm going to tap this one for 15 seconds after. As you can see, it didn't foam up as much. According to livescience.com, a soda can or any other carbonated beverage consists of two key elements that allow the drink to foam when opened. These two elements, carbon dioxide and water, are compressed together in a can at approximately 1,200 pounds per square inch. When a can is unopened and untampered with, it contains little to no bubbles. These bubbles of gas are created when the CO2 and H2O mix. Over time, these molecules will separate again and allow you to open your beverage without the consequence of foam. When you open a drink with bubbles inside, the pressure is then released. However, the gas that has been created by the two molecules combined is also released. Since Coke is primarily water, and the water is attached to the CO2, Coke will come out of the can if it has enough pressure to allow it. The key factor in this experiment is not the molecules sticking together, but the individual molecule CO2 that sticks to the aluminum can. According to Dr. Stu, a graduate from Nottingham University and teacher of science and health, bubbles are formed on a non-even surface at a molecular level. Aluminum is considered an uneven surface at this scale. We can then assume that carbonated bubbles in a Coke can stick to the aluminum when created. This allows us to infer that by tapping on the outside surface, we can pop some of these bubbles. As shown in the experiment, tapping on the outside of the Coke I shook decreased the amount of foam when opened. This conclusion identifies that by tapping on the tampered Coke, you may not eliminate the amount of foam, but you can definitely reduce it.